Good morning and good afternoon, everyone, wherever you are and in whichever time zone you are in. My name is Mohammad Hassan, and today, along with my co-presenter Shafqat, Farhan, Ahmed, we'll be presenting to you the topic identifying and taming N+1 queries. Before diving into the topic, a brief introduction about us that we both work as software engineers at Arbisoft, which is a software services company in Pakistan. In this talk, we will explore how performance can be impacted by N+1 query problem, and more importantly, how we can tackle it and resolve it effectively. Over to the agenda. First, we'll start with the overview of ORMs and how they interact with relational databases. Then we will discuss how performance is important for us in software applications. We'll also dive into what is the N+1 problem actually and how it impacts performance of our applications. We'll show you an example to help identify the N+1 problem, as well as we will look into the strategies to explore, to resolve and to fix these problems, the problem of the N+1 queries. And finally, we will wrap up with some key considerations and takeaways before opening the floor for all of you for any questions that you might have. So let's move forward to the overviews of ORM, which stands for the Object Relational Mappers or mapping, that provide us a layer of abstraction and simplify our database interactions by automatically generating queries for us. So they provide us an abstraction on the top of the database and help us execute the queries more easily and without actually writing the queries by ourselves. And on the top of that, Django ORM, which we'll be using, like many others, it operates on the lazy queuing principle, which means that when we write any operations that deal with the database, they are not actually evaluated at that time, but they are actually evaluated when we actually access the database. While this can be efficient, it also introduces the N+1 query problem, particularly when we are dealing with large data sets where it can be actually problematic. And this problem can significantly impact the performance of our software applications. So next, we'll look into why the performance is actually beneficial and important for us before diving into what is N+1 problem and how it affects us. So why performance matters for us? First and foremost, it impacts our user experience, because slow applications tend to frustrate the user, and in result it results in poor user retention for our applications. And performance issues can also lead us to timeouts on our applications and even random crashes due to the memory overloads. And one important aspect is the search engine optimization, where search engine rankings will be affected if our application is slow and leading to low user turnouts and reduced visibility for us. Ultimately, what all these things contribute to is the low user turnout for our application, and this is the downside of low performant applications for us. So while using ORMs, we have to consider all these impacts of performance. While the abstraction that the ORM provides to us is beneficial for us in many cases, it can also cause headaches for us in many other cases as well. So we have to be mindful of its impact on our applications, particularly when dealing with applications that deal with a large volume of data set. So Let's move forward to the actual problem that we'll be dealing with. That is the N+1 problem. So the N+1 problem in itself is where we have a single query for our actual database model, and in turn it also makes n queries, where n stands for the number of records which are related to our actual call. So this scenario can occur in cases where we have foreign key mappings, foreign key relationships actually, where we have many-to-many relationships, where we are doing some reverse foreign key lookups. And it can also occur for us where we are using templates that execute ORM queries, or we have DRF APIs, Django REST Framework serializer APIs, where the serializers rely on ORM queries that in turn execute N+1 queries. So if this issue is so widespread and so common, why doesn't the Django ORM itself handle this? It trickles down to two main factors, which are performance and flexibility. As we mentioned, that ORMs use lazy loading to minimize the initial query size, which is also beneficial for us with large data sets when we are not going to utilize, or when we are not going to need all of the related data set. But this flexibility comes at the cost of performance in certain scenarios with large data sets and where we have complex relationships. So as an example, we have taken two models here. The conference model, which is a simple model having two fields, and the talk model, which contains a foreign key relationship to the conference table. And next up, we have a use case where we'll try to fetch conference names from their respective talks. So first we fetch all the talks, and then we try to fetch all their talks conferences. So from the outset, if you look at this code, this just looks like a simple code which gets the job done for us. But actually, deep inside that lies our N+1 problem. And for actually explaining that to you and identifying that problem, I'll hand it over to Shafqat, who will help you identify the problem as well as rectify and resolve the issue. So over to Shafqat.
Thank you, Ahtasham. Before I jump into identifying the problem, I want to highlight the importance and the performance impact of the N+1 problem in a software application. First and foremost, it leads to increased database round trips for each query. For example, every time we evaluate the data, a new database query is executed to fetch that data, eventually increases the number of round trips made to the database. This, as Ahtasham has already explained, will result in a degraded user experience, and end users may face low page load times or unresponsive pages. Another performance hit could be that our servers are working harder than necessary, because leading to the suboptimal resource consumptions because of the inefficient query execution. And lastly, with respect to Django REST framework, API's timeout might occur more frequently due to, obviously, as I explained earlier, the suboptimal or the inefficient query execution. Okay, now let's dive into identifying the problem. I'll use the same example that Ahtasham showed earlier with new Django models. Yeah, thank you, Ahtasham. So this is the previous slide that Ahtasham explained. In this, there are two models, conference and talk, which have a foreign key relationship between them. Now let's assume we have 6 records in the talk database table. I use the Django debug toolbar to evaluate the SQL queries executed during the evaluation of the query set. As we can see, there are total 7 queries executed. 1 for retrieving the talks and 6 more, 1 for each talk to fetch the associated data, which is the conference models fields. So this in particular is an N+1 problem because total 7 queries are executed and ideally we should only need 1. Other ways of identifying this problem early in the stages is conducting detailed or thorough code reviews and writing unit tests. Unit tests are helpful because we have an ability in Django to write the unit test to check the number of queries or to assert the query count, so we can tackle this issue in the early stages or before even deploying the changes to the production servers. And there are a few other options. We can use third-party packages that detect this problem, N+1 problem, or the one that I've used is the most commonly used one, which is the Django debug toolbar's SQL window. Okay, so now we'll explore the options that Django ORM provides to fix this problem. There are 2 methods that Django ORM provides to eagerly load the data we required. First one is select related. This is effective in models with the foreign key relation. It allows us to load the related data in a single query, reducing the number of database round trip just to 1. For many-to-many or reverse lookups or for one-to-many relations, Django ORM provides us with prefetch related method. This method performs at least 2 queries if we have just one prefetch related method is added to the ORM query. So there will be at least 2 queries, and then the data is loaded into the memory and the joins occur in the Python code. Okay, so I've explained both of the methods that Django ORM provides. Now let's take a look at our example problem and let's apply the fix. So for the select related, as we've seen in the previous slides, like the talk table, the talk model was fetching all of its data and the related data was being evaluated and additional queries were being executed. So if you can see the first example under the select related section, we have added select related method to the query. What it will do is, so this method will eventually fetch the associated data in a single query. Next slide, please. So here, as you can see, once we have applied the fix, the Django debug's toolbar SQL window shows that only 1 query was executed, and this query is now a bit more complex because it involves inner join operation. But we have achieved our performance. We have improved our performance by just querying the database or reducing the database round trips just to 1. For large data sets, this will bring a significant boost in the performance, especially when we are dealing with enormous data sets. Okay, so as we wrap up, here are some considerations and key takeaways. First, the performance impact of N+1 queries will be minimal on small data set, which is obvious, as Ahtasham has explained earlier. However, as the data grows, so does the impact. And solving the N+1 problem in large and complex data sets can sometimes cause ripple effects. Yes, they do. For example, prefetching large data sets can lead to increased memory usage. So it's important to be mindful of this trade-off, because as we have explained earlier, if we have increased memory, then we might, or users may face server crashes, or server performance might get a hit. So third takeaway is that we should avoid prefetching related data if there is no specific use case. Mindful data fetching is crucial here to maintain the performance. This is why most ORMs work on a lazy loading principle. So it has its own benefits. And finally, we do have to be mindful here, like when working with Django REST framework, serializers, mostly the model serializers, also use or work with Django ORM. So fetching relational data can also lead to N+1 problems there as well. Here are a few resources that are from the Django's official documentation, which you guys can take a look. And yeah, that's all for the presentation. If you have any questions, please let us know. Thank you.